My name is Jacob.
And I am Gabriel, and we are Motion Math. So thank you, Warren, so much for inviting us back here. We're really excited to be here again. And there's been so many changes. Last year we came with a prototype. Since then we've developed the prototype into a product and have launched a company and are making a game suite of math games. So this is our first product. We won't be talking about it today, just wanted to show it to you. It's a fractions app for learning multiple representations of fractions on different number lines. And if you have any questions about that, we'd be happy to discuss it over lunch. But today we're going to talk about kind of more our mission and the six dimensions of math that we see as we do our user tests, as we develop our next products. So why are we doing this? I personally love to develop software. I think of coding and math as similar. Coding is an exercise in perseverance. I believe that these devices can do anything that you ask. It's just a matter of time, time to develop that way of doing it. And math is in a lot of ways the same. Oh yeah. So what happens as we go through the process? Of course, bugs come up. I'm sure some of you who are developing have seen this one. And it's difficult, it's challenging, but I know that if given enough time, I can solve it. And similarly for kids, I think through the user tests, we've understood that they kind of feel the same way about math. There's, although it's hard, it can be frustrating. The look on a kid's face, this is one view of the kid's face being frustrated by math. But after working on it for 5 minutes, after going through one of our prototypes for 5 minutes and finally getting the answer, and granted we didn't scaffold it, but created a situation where they could achieve something, the look on their face is one of relief and a little bit of exhaustion and an exhilarating pride in what they've done. So that's what we like about math. Math is hard, and that's one of the best things about it for creating gaming experiences. It's kind of a paradox on these devices. They're extremely intuitive interfaces. Kids pick them up extremely quickly. We've seen really young kids playing them. We want to continue that trajectory, but we want to create more difficult problems for them to tackle. And these hard problems, they take time and patience to master. Just like the game of Othello, easy to learn, and it takes a lifetime to master. And that's kind of one of the things we want to convey to kids is kind of going off Carol Dweck's work in terms of rewarding kids for effort, not for achievement. So rewarding them for sticking to something, working through it, and getting those moments of inspiration and aha, instead of just, you got the answer right, you got an A in math. It's not so much about pushing yourself as just knowing the one right answer.
So, in addition to the motivation of giving kids that similar feeling that we have of perseverance, another motivation is to give them the power of math. It's an extremely useful tool for understanding the world. And recently, the financial crisis has really brought this home. There's many causes for the financial recession that we're in, but one is that many people couldn't understand interest rates and really didn't understand what a 23% APR would mean when that kicked in. What did their mortgage mean? Because of math anxiety, because they didn't have that fluency with percentages and with compound interest. So we're really motivated to convey to kids how powerful math can be for understanding the world and to not get tricked. That's actually a game dynamic that we're starting to play with that I think all kids and adults can really get behind. Don't be a sucker. Don't get fooled. There's people out there, including a lot of fine print on financial statements, that's trying to trick you. If you know math, you won't be tricked. That's part of our motivation. So really, the mission of our company is to explore the research, to explore in many user tests, What are the foundations of math? What impedes understanding the foundation? What aids it? And then how can we give kids a mastery of these foundations with delightful play? Really exploring these new interfaces to see what are the new ways we can give kids a master of these foundations. In doing our user test, we've now gone out to, we're on a weekly, it's like a gauntlet. We're putting ourselves through a gauntlet of user tests. Every week we go out to a new school, try to really vary charter, private, public school, different areas, to check out our new prototypes. And it's extremely mysterious what kids understand and what they don't, and how they're able to verbalize certain math concepts and then display no understanding of it whatsoever. Or they understand total fluency but can't verbalize it at all. So really getting into the weeds of what are those concepts that are necessary to build up to these foundations. To give one example, we really started to tackle decimals. Decimals are crazy hard for kids. Once you put that dot there, numbers change, numbers are getting smaller to the right. And one example of this is 0.8, 0.9. You have them lined up on a number line. And where does 0.10 go? And almost every single kid, and most adults, many adults too, will put it right 8, 9, 10 right in a row. Who else? Raise your hand. You don't need to be embarrassed. Well, actually, our efficacy partner is a professor at USC who has a PhD in assessment, and she felt for this the first time, and that was like, yes, we have found something tricky. But in fact, 0.10 is the same as 0.1, and it belongs over there on the number line. A difference between adults and kids is that if you show adults this trick, or you put your finger over the 0, and they go, darn, okay, yeah, it's 0.1, or you add a 0 to the 8 and the 9 to show those are 0.80 and 0.90. If you show the trick, the next time they'll get it. And a lot of kids will see this, they'll move it over to the right place, they'll say they'll get it, but if you show them a very similar problem, 0.20 or 0.11, it's gone. There wasn't really that real understanding. Maybe they learned it in this one scenario, but there's not a real comprehension of why that trailing 0 is meaningless. So how do you give a kid a deeper understanding of a concept like decimals that isn't just particular for one scenario? How do you give them a transferable knowledge that can move into many different domains? And one great way to do it is to give multiple representations, and that's part of what we're excited to do now in our math suite, is to take some of these same concepts and show kids all the different ways. Dollars and cents is a very intuitive way that many kids understand decimals, and if you ask them, kids who are just learning decimals, what does that mean? They'll often say, oh, that's for cents, which gets a little trickier once you get past hundredths, but it's a good beginning, very concrete representation. Blocks, physical representations, or virtual manipulatives. We're creating movable objects in the interface that correspond to numbers, or visuals that really captivate, that really capture the essence of an idea. This is the brilliant Ames film, Powers of 10, that really shows at each level getting bigger and bigger, starting at the molecular level, moving up to someone's hand, the picnic, a city, the whole universe. An image that really sticks with kids. But even if you have multiple representations and a kid is working fluently with, they can add up pennies and dimes into a dollar, they can arrange the blocks, it's still procedure. And I think, as Warren mentioned earlier, our first game really is, in some ways, procedure, jackhammer, if you will. There's a place for Skinner in education. There's certain things you just need to get automaticity with. You can do it in an intuitive way. You can do it in a way that's more fun. We hope to do a much more fun version of learning fractions than out there, but it really is procedure. And with every new tool, like the abacus, the calculator, new procedures become possible, and also new fluencies are expected. And that's part of what math is, and kind of accepting that there's no way to do some of those higher operations without having decimals, for example, be really automatic. For this example, this procedure of doing long division shows the limitation, though, of this aspect, this dimension of math. And we got it through talking through it with a great teacher, Jun Fuji in Palo Alto, who always asked students at this point in the long division problem, why does the 2 go there? You have 36, 75, it goes in 2 times. Why does the 2 go above the 5? And many kids will say, well, because that's what my teacher told me. That's not a good reason. That's not a reason that is going to show transfer to other areas. That's actually going to that actually shows a comprehension of the concept of why. Because I've done it every time, because that's how you do it, because that's how my teacher told me, because that's how they line up. Maybe it's a little bit better, but it doesn't really show procedure. So another dimension of math is that math is articulation. Math is being able to communicate reasons for the procedures, abstractions, other representations, your own representations. And that's how we're trying to push ourselves also, is to think, how can we make math very personal? Once a child can describe in their own words or create their own scenario or their own set of tools or their own problem, that shows a much greater kind of understanding than just being able to correctly work through your procedure. And if a child can teach a concept to someone else, then they've really mastered it. So whenever we create a procedure, obviously when a kid gets it wrong, you want to ask, well, what's confusing? How can we scaffold it? Are there hints we can give? But I think even more so when they get it right. For instance, in our first product, how did you know where to put the fraction? And if the answer is just that's where it goes, it's okay. But much better is when a kid can say, well, when a fraction divides something up into parts, and that was 2 out of 3 parts, and that's where it goes. That's showing a much greater comprehension of the concept and not just the procedure. In literature and in the humanities, students really can make the materials personal by creating their own versions. There's the whole great genre of fan fiction, where students have kind of become the characters and created their own. So the question we're asking is, what would math fan fiction look like? This is a picture from the web of some probably tween girls imagining of Twilight and Harry Potter came together. We love it. So what would fan fiction for math look like to give kids the tools to really own this material?
And kind of the sixth dimension, the last dimension that we explored, really the poster child for this dimension would be a student that we went to at school. Her name was Beatrice. Beatrice just got excited about the game. She about just a prototype of our next game. She started playing it. She tried to make up answers and patterns for what we were trying to accomplish. And in the end, we asked her, how do you like the game? She said it was great. It was a lot of fun. And we asked, well, why is it fun? And she said, because it's math. And that's really an attitude that we're finding a lot in the classrooms that we're doing. And maybe it's just the age groups that we're looking at, 3rd, 4th, and 5th graders. But they kind of enjoyed the challenge of it that we were talking about. The mystery of it makes it something that's interesting that they can go after. The power of it, they see that math can be powerful in the world. They are learning this for a good reason. They can take it home and use it a little bit, what they learn. And all that brings us to math being fun. I think one of the most inspirational talks from the last time we came was Darren Karsten's talking about how learning is fun. And we truly believe that, and we really see that with the kids that are out there. It's already kind of a game to them. We're just calling out how interesting it is. we're calling out not only how interesting, but also its beauty. This is, this is a fractal. Fractals are amazingly beautiful things. You can do so much with them. Math is extremely powerful. Large Hadron Collider uses massive math and physics calculations done all the time to be able to find out more mysteries in the universe. And finally, math can be whimsical too. This is from Vi Hart, amazing mathematician, and it's just it permeates our lives, especially in this highly technological society. And so, really, the mission of our company is to show off these aspects of math and to create, to not only show the beauty and power of math, but to create an experience where every student can feel that they master it. And so that's what we have, and we are interested in continuing this conversation as more of a Q&A, or we can throw out some questions to the audience.